Okay, so we're gonna look at employment and unemployment stuff, and hopefully this is gonna be like way quicker because there's way less stuff to learn. It's all like pretty simple stuff. Okay, so let us start. So first of all, some terminology. N is the working age population, so like people like, I don't know, 18 and above, 18 to like 65, I guess. U is a number of people that are unemployed. E is a number of people that are employed. Q is a labor force, which is unemployed plus employed. So there's like the labor force, which is like people who are either like looking for jobs or they already have jobs, versus people who are like, for example, like stay at home, people, or like people who are students, for example, things like that. So that would be like the opposite of Q, like 1 minus Q or whatever. So we have the unemployment rate, and that is unemployed over the labor force. I mean, the what? What? Okay. Wow. Maybe it has to do with this? Okay, this is weird. This is not what I learned before. So unemployed is the unemployed people over the working age population. Employed is the employed people over the working age population. And then the participation rate is the number, like the rate of how many people are actually like participating in the labor force. That is E plus U, which is, labor force, all over the total number of people. Okay, so this is like, it's pretty simple stuff. So one thing is we're assuming that N equals Q equals 1. So we're assuming that all the working age population is all the same as the labor force, which means that, like before, there are no stay-at-home parents or students who are, unemployed because students who aren't looking for work because they're students and studying. So just like everybody has a job or is looking for a job in this universe. Like everybody that is in the working age population. And also, it's all equal to 1, and the reason it's equal to 1 is just like for simplicity, because then we don't have to deal with stuff like percentages and all that. So, later on, if we were to be like the value of, oh, what the hell, the value of N equals 0.95, then we can just use that as like, the rate of people or whatever. Well, anyway, it'll get easier later on, like you'll understand later. Okay, so next we have VE, which is the value of being employed. So like it's like the utility from being employed. So like, yay, I have a job. And then VU is the value of being unemployed. Now you might be like, oh, but there's no utility, or like there's no value to being unemployed. Well, we'll see. We'll see later on. So one thing is, so some other terminology that we got to learn. S is a separation rate, and basically separation rate is a rate that you are, like a probability that you're separated from your job, which means the probability, I think it means a probability of you losing the job. Like it kind of makes sense with everything else that we're talking about. So, cool. So this is like separation rate only really matters when you are employed, because that's when you're like worried, like, oh, am I gonna lose my job? Like, what is the probability of me losing my job, etc. It's just like a thing that we'll use later on. So this is what the graph comparing like employed versus unemployed looks like. So it's like, so first of all, the value of being unemployed is just like a number. It doesn't really depend on anything. So just like a number, let's say like 12 or whatever. Whereas the value of being employed depends on your wage. So it's like increasing as a function of your wage. And another thing to note that it's concave or convex. I don't know which one. I think it's concave, which means that, like it's not like as your wage goes up and up and up and up and up, like let's say your wage is like $1 million or whatever, you're not gonna get that much more of a benefit from it, like the diminishing marginal utility and all that. So it's like it like flattens out when you get the top. So the point at which the value of being unemployed and the value of being employed is the same is called the reservation wage. And this is basically the point at which you would decide whether or not you should get a job. So for example, if your reservation wage equals $13 an hour, I guess, and let's say that you get like a new job offer and they're like, okay, so you're gonna be paid $10 an hour, you're gonna be like, I don't think so. This is way less than my reservation wage, so you're gonna reject the offer. like there's the reservation of the wage is like the way in which you decide like whether or not you want to do it, whether or not you want to get the job. And whereas if the wage that they're offering you is like $20 an hour, you're gonna be like, damn, that's pretty high. I will take the job. So that is that. Um, some other terminology. So like this is some other terminology that's sort of whatever. Anyway, some other terminology is B stands for the EI benefit, and P stands for the probability of receiving a job offer. So remember how I said there's value to being unemployed? So the value to being unemployed is these two things. So first you get, your unemployment benefits if you don't have a job. And second, if you don't have a job, then it's not like you're going to be unemployed forever, right? You'll probably get a job soon. So basically, like the probability of you getting a job sort of adds on to the value of being unemployed. So I think this, like in our design, we've made it so that the N equals Q, which means that everybody that could work is working, or like is in the labor force, I mean. Whereas I think for these two, it's sort of have to imagine like the possibility of you not having a job. So like if you not being in the labor force. So let's say like there's two people, one is unemployed and one person's like, I don't know, a stay-at-home person, mom or whatever, dad or whatever. So basically this guy over here would get like an extra benefit because this guy has like the probability of getting a job. He has a possibility of getting a job. Whereas this guy over here just like stays there, like doesn't really, there's no possibility, like there's no like opportunity or whatever. So there's none of that benefit. So that also adds on to the benefit of being unemployed. So there is value to being unemployed versus like not having a job, like not like looking for a job, I mean. So two things: if your EI benefits or the probability of receiving a job increase, then the value of being unemployed increases. And if your separation rate increases, then your value of being employed decreases. So your separation rate is like the probability of you losing your job, right? So if that thing increases, then you're going to be like, oh my god, I'm going to lose my job easily now because it's, the separation rate is higher. Which means that the value of being unemployed is like lower because I'm like stressed out or whatever. So it's not like, guaranteed, for example. So now another thing to note is that this might be confusing, but if the value of being unemployed increases, the value of being employed also increases. This might seem a bit counterintuitive because, they seem like opposite stuff. But thing is, it's true, but like it increases by like a very tiny amount. So basically how it works is like, let's see, I could be unemployed with a probability of S. Okay, right. So the thing is, if I have a job and like I have like a job, here's my little suitcase or that I bring to my briefcase that I bring to work. There's a possibility that like I could lose my job, right? So it's not like I'll be there like forever, I guess. And there's the probability of me losing my job is S. So let's say that I lose my job and now I become unemployed. Now, if my value of being unemployed is like really low, that means that if I were to lose my job, I would be like so sad, which means I'm like super stressed out at this job because I'm like, I can't get, fired or whatever. So the value of being employed would fall down if the value of being unemployed would fall down. And by the same thing, if with unemployment I have like really high benefits, like let's say like EI benefits are like really high, and the probability of me getting a job again is also like really high, then my value of being employed is pretty high too, because like it's not so bad if I were to lose my job. So you have to think about it as like a cycle, like the cycle of being unemployed then employed, and that's how it works. Okay, so here's the cycle I was talking about. So when you're unemployed, you get to being employed, and if you're employed, then you get to being unemployed. So now the process of being unemployed to employed, like the formula for that is UPHW. So U is a number of people who are unemployed, and remember, since like we have since we have like N equals Q equals 1, then this U, since it's like this, then the U is something like 0.25 or like 0.36, right? Like it's not gonna be more than one, it's like it's all in percentages, for example. So in this case, we don't really have to worry about like the percentage rate and all that because it's like basically already in percentages. First of all, from being unemployed to employed, so so you have to take the people who are unemployed, so you, and then you multiply it by the probability of them receiving a job offer, P. You have to multiply that by the probability that their job offer, the wage that they're offered, is higher than their reservation wage. So remember, people only receive, they'll only accept a job if their wage that they're offered is higher than the reservation wage. So HW is just like higher than reservation wage, like just like a function here, which we will look at. Oh, why is this all black? Just like a function here that we'll look at. And so basically this is the amount of people that are unemployed to employed. It's like the people who are unemployed, who get a job offer, and whose job offer has a wage higher than the reservation wage. So that's the employed. So now to go from employed to unemployed, well, first of all, you start off with the employed people, so 1 minus u, and you multiply it by the probability of you losing your job, which is S, remember the separation rate, and that is the people who become unemployed. Great. Now that we have that, I probably should have done this little graph before, I guess, because it'll make more sense. But basically, HW is like the probability that the wage is higher than your reservation wage. So, one cool thing, not really cool thing, but like one thing is that as the wage gets higher, this H gets lower. And why is that? Because if the wage is higher, like let's say, yeah, if the wage is like super duper high, like $20 versus like very low, like I don't know, $5, then the probability that your wage that you're offered on your offer letter is higher than 20 is very low, but the probability that's higher than 5 is pretty high because, like, high small number, right? So basically it's like downward sloping to show that like the probability of the wage being higher than the reservation wage is it decreases. Great. So next, oh, this keeps happening. So now that we've gotten that over with, let's put the two graphs together. Like the two employed to unemployed versus unemployed to employed line together. So this line over here is so the unemployed people who get a job offer, whose job offer wage is higher than their thing. So this is the people who go from unemployment to employment. And this thing over here is the people who are employed, but there's a probability of them losing their job. So this is the people that go from employed to unemployed. So it's just like opposite things, and then here's like the equilibrium rate of unemployment. So it's like as a function of unemployment, and at equilibrium we have this thing over here. So this is like a steady state, which we went over before, like just like basically equilibrium. And at equilibrium it's like this. So beautiful. So now we're gonna put it all together. Wow, it's like almost done. So first of all, we have our original graph with our value of being unemployed and the value of being employed, like this. And this one, oh no, what the hell is this? Damn it. Oh, there we go. And this thing over here gives you your reservation wage. And this graph over here is our graph that shows us going from employment to unemployment and unemployment to employment, etc. And this thing gives us our equilibrium or equilibrium unemployment level. So it's like equilibrium, yay. So just like usually, so if we're ever gonna look at changes in certain things, like changes in S or changes in P or H isn't a thing. P, whatever. I don't know, whatever. What? Separation, nope. Probability of getting a job. Damn. Oh, B, okay. Oh, EI benefit. And all that stuff. So when we look at like changes in this stuff, we have to look at the effect on these two graphs. Okay. So first, so we only have like two things to go over. So first, like two little experiments to go over. So first, if the B increase, so if the EI benefit increases, that means that my value of being unemployed increases, right? Because I could get like a better benefit from like being unemployed. This doesn't affect the VE because VE is only affected by the separation rate, right? And one thing to note is like, remember how before we said that if VU rises, then VE also rises? Well, it's true, but like the VE increase is like really small, so like it's not on the graph. So first we have this thing where we have like a new graph. So our reservation wage increases. If our reservation wage increases, so like we have like a higher wage at which I'm gonna be like, well, I'm gonna reject it if it's below, I'm gonna reject this job offer if it's below my minimum wage, my reservation wage. It's gonna make it harder for people to get jobs, right? Like it's harder to get a wage that's higher than that new higher wage. So because of that, this graph goes down because this wage increases. And since the wage increases, the HW decreases. Remember, we have like that if wage increases, HW decreases. So because of that. So this thing decreases, so it goes downwards. So like unemployment goes up. Let's see. Cool. Yeah, okay, great. Let's see. Yeah, that's kind of it. So number two is if the P increases. The P is a job offer, right? The probability that you get a job offer. So again, if this thing increases, then what happens? Well, as an unemployed person, I am more like in benefit, you know, because like it's like, wow, it's not so bad being unemployed because the probability of me getting a job offer is actually pretty high. So again, just like before, the VU increases to another one. So it's like W2, blah, blah, blah. Now you might be like, just like before, this thing has to, you know, decrease, right? No. I mean, it doesn't really have to. It could. But basically, there are two effects here. If you notice, this P here is the same thing as this P over here. Like, that's the actual equation. That's not related to, like, this wage here. So there are actually two effects. One is a direct effect, which is that when P increases, this P increases, so this thing increases. So we would have to, like, make the graph go upwards. And there's also the indirect of the fact that the wage is increasing. And since the wage is increasing, the UPH has to decrease, so we would draw it downwards. Well, in this case, I have drawn it so that the direct effect is greater than the indirect effect. Wow, it sounds weird. Anyway, so in that case, we'll be drawing the new graph above, so it goes upwards. So it goes upwards, and our new unemployment rate is lower. If we had drawn it the other way, then like, you know, the new employment would have been higher. But like, you know, that's like your option. So yeah, I think, yeah, that's it. Okay, bye.